So we are given the Nucleo board with the name Nucleo F439ZI. Some of the specification of the board are given here. Some of the common features are the STM microcontroller. This comes with the LQF4 FP4 144 package. It contains 3 user LEDs, 2 user and reset push buttons. It works on 32.768 kilohertz crystal oscillator. There are board connectors with it, which we can connect with the Arduino. It support flexible power supply options with the ST-Link USB V-bus or external sources. It can withstand onboard ST-Link debugger or programmer with the USB remuneration capabilities, and comprehensive free software libraries and example available with the STM32Cube MCU package. Some of the board specifications are like external and internal SMPS to generate core voltage logic supply, Ethernet compliance with the IEEE 802 variant, USB OTG full speed or device. And there are also board connectors like USB with micro AB and USB Type-C Ethernet. And it is enabled with ARM embed enabled component. So this board has, so these are some of the features of this board. And as we can see here, the board looks like this. So the user LEDs that we are going to toggle today is present here. 3 LEDs. There are green, blue, and red LEDs. The LED one is green. Next is blue, and the third one is red. And here is the power LED present. There is another power LED which is green LED, and this common LED which is red or green LED is present with the board. There are some other, these are the output and input pins available here. And we are given 2 user buttons. The one button which is in the blue color is the user button, and one with the black one is the reset button. So now we are going to start the STM32CubeIDE, which will help to program the board. So I'm going to create a new project here. It will automatically start downloading files which we are going to require. Okay, so this is where we are going to select our board. So this is our board name. So I'm going to select it here. So we will select the board and continue. So I'm going to give it a name. So we are using all the settings in the default mode, and it will automatically start creating a template for the board. Okay, so here these are the pinout configurations for the board here. As we can see here, and this is the green LED named as LD1. Here, this is the red LED named as LD3, and another one is LD2 blue LED. So other things are clock configuration, where we can see the clock things, and the project manager, where all the folders are and all information is present, and some of the tools where we can see the current and voltage information. So here in the left side panel, we can in the project explorer, we can explore the things in the core. We have include, source, and startup. So in startup, there is a file startup underscore stm.s. Let's open it. So this is the .s file in which all the setup is being made. So let's keep it as it is. And in the source file, there are .c files, main.c, stm32f for access.c, stm32f for access.id.c, system call, system mem, system underscore stm. All these files are we are going to code in all these files so that we can program our board. So so we are going to program our code in main.c file. So let's open it and see. So first of all, in main.c, it includes main.h, which is included in this folder. So first of all, it being included, and then now we are going to start with the code. So first of all, initialize the system clock configuration, then GPU, Ethernet, user start, and USB OTG. So with the starting with the main function, first of all, we have initialized the HAL operation, which is hardware layer, and then we are going to initialize the GPIO because we are going to work with the general purpose input output pins. So there are other initializations also, Ethernet, user start, USB. So so we do not want these initializations, so we are going to comment these out. And in the while loop, we will write our code. So in the code, we are going to look at the user manual. So in this user manual, there are various HAL instructions. So in today's lab, we are going to only look at the GPIO pins. So here comes the HAL GPIO generic drivers. So there are various instructions available here. So we will go to the simple input output operation functions. So there are various functions contained in it: LGPIO read pin, write pin, toggle pin, lock pin, GPIO, external IRQ handler, and callback functions. So today we are going to start with the toggle pin operation. So instruction. So this toggle pin operation, it will start with the function name like this, and it contains two inputs. It will take the definition type of GPIO and the pin number. The function, it toggles the GPIO pin. There are these two parameters: GPIO pin, which specifies the pin which is going to be toggle, and the GPIO X, where X being the peripheral name. It returns nothing but just toggle the pin. So we will write hell GPIO. So this will automatically give us suggestions. So in here, GPIO X. So as we can see here, that our pins contains the PBO, PB7, and PB14. So the peripheral of these pins is B. So we are going to start with here with B, and we need to write the name of the pin. So the name is LD1. Now the next instruction is we are going to give it a delay. So usually the delay given here is in milliseconds. So I'm giving it 200 milliseconds. Now there are 3 pins. So we will again giving the same input with the other 2 pins. So for formatting the whole document, we use Ctrl+Shift+F. It will automatically format the document. So now we will go to this hammer option. This will automatically connect the board with this software. So now we are going to debug this. So we use debug as and STM32 Cortex. So now we will keep all these things in the default manner, and it will automatically check for the debugger connection. Now we switch it on. Now it points to the first operation. So there are 2 options. First is resume and another is step over. So if we step over on it, then it will execute one function. So when I put my pin to here, then it will start one LED and then give some delay, and then it start another LED and then give some delay, and then it start the last LED and give some delay. So in this way, the whole loop will continues. So if we put on resume here, so it will automatically runs the code. And to terminate the action, we will stop here with the terminate. Okay, thank you.